Welcome to the first video. This video will show you the full disassembly process, starting with removing the strings. In order to get to anything else in the guitar, we have to get the strings out of the way. These strings were very old, although they didn't have any finger buildup, oil buildup, or anything like that on them. They were kind of rusty. You can kind of see it in the video. There's some little spots of oxidation on the strings, so it was good to get them off. They didn't feel good under the fingers, typical for old strings. I gave up using that string winder because of the rig holding the camera. Makes it difficult for me to get in there, so I did it by hand. So one of my objectives here was to just simply save this guitar from the landfill. It's always a shame when guitars that are in rescuable shape end up just in a landfill. That's always a bummer to me. I have a soft spot for guitars, obviously, and it's just a shame to see guitars that can be saved just discarded. So now it's time to take off these tuning machines. They used a 10mm socket. They're held in place with this threaded ferrule. That does most of the work. But on the back, you'll see in a moment, there's also a screw that has to be removed before these tuning machines will come out. That screw's job is mostly to keep the tuning machine from rotating when it's under torque as you're tuning the strings. You can see each of those 6 tiny screws there. It's important to use the right size screwdriver whenever you're doing work on a guitar, or really anything. If you have problems stripping screws, it's probably because you're using the wrong size screwdriver for that screw, or because someone has worked on that screw before you and they used the wrong size screwdriver and stripped the screw for you. The feel of the tuning machines is really good. So that was a relief, because if tuning machines are broken, there's not a lot you can do with them. You just had to replace them, and that would be a cost. So it was nice that they were in good working order. Here I am just putting the tuning machines back together with their washer and their ferrule. That way everything's together and they don't get lost. If you have old Tupperware that are kind of grimy or just kind of been cooked with too much, they have those little spots all over them. A good thing to do is to use those as a parts container. When you're taking apart your guitar, you just dump your parts into those containers and you know exactly where they are. Alright, so these little guys are called string trees. Their job is to make sure that the string crosses over the nut, that's that white piece, crosses through the nut and to the tuning machines at an angle that keeps them secure in the nut. In my opinion, string trees like these are a little bit overkill. Probably only one was needed, and they weren't needed so close to the nut. The break angle over the nut was a bit too severe, and it would have caused unnecessary tuning problems. So what I'm doing here is I'm just making sure that the truss rod is actually working. I want to find out as early as I can that the truss rod actually functions. Otherwise, it's going to be a pain in the butt later to do a setup on this guitar. The truss rod allows the guitar tech to manipulate the curvature of the neck. This back plate, on my Strats, I generally do not keep the back plate on the guitar. I find it to be just a nuisance. So I usually just take it off and put it in a Ziploc bag and store it away in case I need it later. But that's just my preference. I didn't want to do that on someone else's behalf, so I kept this back plate, and I'll show you later how I flattened it out. I got it looking pretty good. Alright, this bridge assembly is held in place with the traditional 6 screws. These screws are kind of special. You can't just use any screw because the very top portion of the screw, just under the head, has a non-threaded part. The bridge plate actually pivots against that non-threaded part. See, this bridge is a vibrato bridge. It's meant to pivot against those screws so that you can manipulate the strings using the vibrato bar, the whammy bar as some people call it. So those screws actually had to be a specific screw. So it was nice that these screws were in good shape. Again, I didn't have to, replace them. You have to replace them with specific screws made for this purpose. So all right, these are the vibrato springs. Now, the traditional way to call this whole unit is a tremolo system, but that was Leo Fender, the inventor of the Stratocaster and this system. That was his mistake. He kind of misused the word tremolo when vibrato should have been used. But anyway, those were the vibrato strings or trem springs. They were the last thing holding that bridge to the guitar. See how grimy it is in there? So as is the case with most Strats, with the exception of the post-CBS Strats from the 70s, this neck is held to the body with 4 screws and a neck plate. Right. And they were in great condition, which is also great to see. I don't think this neck was ever removed because there was no wear at all on the screw head. And again, it's important to use the right screwdriver for each screw. That will help you avoid stripping the screw head. That center hole, I'm not actually sure what that center hole is for. Maybe for alignment at the factory. That would be my best guess. As you can see here, the neck is in good shape. There's a very flat surface where the neck fits in the pocket, which is very good to see. Alright, so I have my trusty soldering iron set to 668 degrees. And what I'm doing here is I am tinning the tip. That's putting a little bit of solder on the tip. I probably put more than I needed, but that's alright. And the reason why I'm doing that is because the next stage in this process is I have to remove the ground wire from the spring claw. Now that ground wire is attached to the spring claw with a solder connection. Now since the spring claw is so big, it's a very good heat dissipator, so it's very difficult to get that joint up to temperature. without risking like burning the insulating rubber on the wire. So to help with heat transfer to the joint, it's good to put a little solder on your tip, and what that does is it creates a larger surface area of connection between the soldering iron and the joint. It still took me about a minute to get that joint hot enough to remove that wire. It's always tricky, at least for me. Now, if this pickguard was a standard fender shape, I would have just replaced the pickguard. I would have spent the $20 and got a brand new pickguard. The pickguard is kind of the face of the guitar, and you want it looking its best, right? So I would have preferred to have just bought a new one. That would have been the easiest thing. Definitely worth the $20. But for this pickguard, I didn't really have that option because it was unique to this manufacturer. It's not exactly the same shape. The holes are in a different place. So the best option for this pickguard was to try to flatten it. And I'll show you that process later. So I removed all the screws except for this one here. This one was very rusty. I tried multiple screwdrivers. I couldn't get a screwdriver to really bite into the screw head at all. The screw head was stripped, and it basically was just a crater. There was nothing to grip into. So I tried this hack that works sometimes. Didn't work this time, spoiler alert. But you take a piece of rubber band, you put it over the screw head, and you screw down into it with your screwdriver, and hopefully this rubber band will fill the voids in the screw head and allow you to bite into it and remove it. It works best in situations where the screw head is not super tight, like the screw isn't super tight in whatever position it's in. But in this case it is. It's a wood screw, so it's too tight. I couldn't get it to bite at all. So I had to use the nuclear option, which was to make my own slot in the screw head so that I can put a flathead screwdriver in there and take it out. This option worked. I still had to fight with it. You'll see in a moment. I used a Dremel tool with the cutting edge on there. And all I'm trying to do is just create a slot across the center of the screw head so that I can put a flathead screwdriver in there and twist it out. Now, you probably see there, I nicked the pickguard a little bit. That was inevitable. There's no way I could have avoided that as far as I know. Not with the tools that I had. So I left a little souvenir for whoever gets this guitar next. They now know I was here. I left a little nick in the pickguard. So as you can see, this process has taken quite a long time. When you're a guitar tech and you run into little issues like this, it really brings the mood down in the room because you're flying along, everything's going great, you're disassembling, everything's moving along great, and then you just have this one screw that is taking as long as the rest of the project is taking to remove this screw. So it was a relief to get it out of there. Look at that thing. It is rusty. So glad to get rid of it. It's out of there. Okay, so the pickguard is still attached to the guitar, in one place. This wire here, that's the ground wire that I had to desolder from the spring claw that you saw earlier. The remaining wire is the ground and hot lead that goes into this output jack cavity. That lead has to be desoldered from the output jack before I can remove the pickguard completely. So there you see it. So out comes my soldering iron again. I put a cloth underneath of it so that if there's any solder drip, it doesn't drip onto the surface of the guitar and create yet another blemish on this beautiful but disused guitar. Try to do no harm, as they say. So I'm just heating up the joint so that I can pull away. You can see how fast this is compared to the spring claw earlier. That's because there's not a lot of metal in this part. And metal dissipates heat. So I'm trying to put heat into the joint and melt that solder. But if the joint is connected to a lot of other metal, that metal is going to absorb that heat and I won't be able to get enough heat into the joint quick enough. But in this case, those little tabs, they soak up that heat, get really hot very fast, and that solder melts almost instantly, and it's easy to disassemble. Alright, now I'm going to tighten that output jack connection now that it's free. It's the best time to do this. 11mm socket. I hold the back side with my hand and just twist with the socket driver, and now it's tight. Now we're good to go. Now the pickguard is completely free. You can see that it's a bit warped, but at least I can put it aside and show you the top and bottom here of the body. Beautiful piece of wood. It's actually 3 pieces of wood glued together, if you look closely. Alright, now it's time to take all of the electronics off of the pickguard. The pickups, the tone knobs, the volume knobs, all that has to be removed. The switch. You can see the plastic is still stuck to the pickguard there. That's very common on Fender style pickguards. $11mm again. This, you could just use your hand to loosen these. You don't need a socket driver. There's a washer under each of those nuts. So I'm just collecting those, putting them to the side. There you go. See, the washer just stuck to the magnets that are part of the pickup. They're not actually magnets, though. I'll talk a bit more about that later in this video. Alright, now we got to get the switch off of there. It wasn't coming off because I didn't realize that there was a nut on the back, so I have to keep that nut from spinning. So I grab my pliers so that I can hold the nut in place while I unscrew the machine screw. And now you get to witness me struggling here as I try to grab a hold of that tiny little nut while unscrewing it from the other side. But I got it. All right, it's in good shape, which is good to see. Again, I try to keep parts together that belong together, so I just put that nut right back on the machine screw so that they stay together. All right, and then off with the other screw. Now this is a typical 5-way selector switch. Most modern Strats have this switch. Not this particular brand. This brand is a very inexpensive brand you find on, budget guitars like this one. It allows you to select each of the pickups individually. That's 3 of the positions, or 2 pairs of the pickups. 2 different pairs. That's the other 2 positions. So that's how you get your 5-way. All right, again, I'm just putting the washer and the nut on each of the potentiometers. That was for the volume and 2 tone knobs, just to keep those together. Okay. Now the only thing holding the electronics onto this pickguard are the pickup screws. Now these pickup screws serve 2 functions. They of course hold the pickup to the pickguard. And for those of you who don't know, pickups are like the microphones of the guitar. They are the devices that listen to the vibration of the strings and transmit that signal to the amplifier. So these pickups are what make this an electric guitar. But these screws, as I was saying, they have a spring in them because they also allow you to adjust the height of the pickup in relation to the strings. The closer the pickup is to the strings, the higher the output. You get too close though, and you'll get these weird wolf tone artifacts in your playing. So finding the balance between having good output, good tone is important, and that's what these screws allow you to do. So the springs have to be there, otherwise the pickup wouldn't stay where you put it when you adjusted its height. So if you look closely at the back of these pickups as they're being removed, you'll see a gray rectangle. That gray rectangle is a bar magnet. Typically on more expensive set of pickups, single coil pickups that is, you won't see a bar magnet. The magnets will actually be the pole pieces, which are the circles you can see on the face of the pickup, like right there. Those are the magnets in a typical single coil pickup. But to save cost, the budget pickups will use a bar magnet underneath of the pickup instead of using the more expensive pole pieces. And why that is, I'm not exactly sure. I imagine it's because it's easier to machine a large rectangle than it is to machine small little slugs. I think it's just manufacturing. So in this particular pickup, the pole pieces are magnetized by the bar magnet, but they're actually not magnets themselves. All right, so we have a very warped pickguard. We can see it in plain view now. Very warped in a lot of different dimensions, but in a later video I'm going to show you how I flattened this out. It wasn't perfectly flat, but it was much flatter than we see here. All right, thanks for watching this video. Stay tuned for part 3.